Welcome back to the next session in the Channel 3. Our next session is ABS Brakes with Ben McNamara. Take it away, Ben.
Good morning, everybody. My name is Ben McNamara. I'm with Aviation Product Systems. I manufacture the APS black steel brakes, as well as some other PMA products. We're getting into a couple of different areas to expand our base, and but we're located in Granite City, Illinois, which is where our corporate office is, which is right across the river from St. Louis. And just want to talk to you today about the black steel brakes, my black steel brakes, and to go along with that is the PMA process. I want to just discuss what it takes to be able to manufacture a PMA part and to get it legal and able to manufacture to sell to the aircraft users out there. But we'll talk about the history of APS. We've been around for a few decades, again, the PMA process, that's the big part of this. There's some pretty stringent amount of work that we had to do to get the PMAs. The manufacturing quality control, that we're just going to talk about what I have to do on my products to get them ready to sell. The product improvements, at APS, we're always striving to make a better product, and we want to have the best product out there. And right now we're pretty confident we do. So, but again, I want to talk to you about the lining and disc break-in procedures. Now, this is very critical on this, and we'll talk about why it's important to do that to get the life of the life you should out of your brake linings and brake discs. And then just talk about a couple of other things with the basic maintenance and then the additional PMAs that we have coming out. But in '93, as you can see, the APS started out as AvPro, which came from Appalachian Accessories, which used to do the same brake linings and brake discs that we do today. Now, with that, some things have changed. At the time they only had the PMA on the 5 and 6 inch disc, and then some of the more common semi-metallic and metallic linings. We have since broadened everything to where we have developed support for everything that has the Cleveland wheels and brakes. But 2000, the current owners purchased AvPro, and again, it was just the 5 and 6 inch disc where we were doing all the machining, outsourcing all the machining at this point. So that said, we wanted to go the full gambit and get every brake disc and brake lining that Cleveland has for this style of brakes. So we expanded into the 8, 10, and 12 inch discs, and then added some more semi-metallic and metallic linings. So about 2005, we invested in a machining company, and we brought all machining in-house, where we started with one CNC horizontal lathe. And at that point, we changed the name from AvPro to APS, which stands for Aviation Product Systems. Okay, 2009, we added another lathe, and 16 the same thing. But now I believe we have 5 horizontal lathes that are running 10 hours today, 10 hours per day, 2 different shifts, 5 days a week. So With that, we have been able to cover all the aircraft that use this style of brakes, and the demand is growing out there with everything that's going on in the industry. But with the PMA process, the parts manufacturer approval process, under Title 14 CFR Part 21 Subpart K, that's what lists all of our regulations that we must follow to and the procedures thereof to get to the approval to do what we have to do to be able to make our products. So the FAA spells out the PMA part has to be an approved identical part, which is a direct replacement for that of the OEM, on the linings and the disc both. It must be equal to or better than that of the OEM. So Cleveland, the OEM Cleveland in my case, is the baseline. So I had to meet or beat that of Cleveland on a comparison test basis to be able to move forward with the products. So that said, it can slightly be modified to improve the performance or reliability thereof. What we've done, as you can tell, we have our brake disc are black. That black color is not a coating. It is an actual byproduct of the heat treatment we put our disc through, which we'll get into here in a little bit. But with the PMA process, when we started off, after we purchased this company, the PMA process starts where you have to identify a part that you want to PMA. Okay. For this case, it was the 8, 10, and 12-inch disc. So we had to reverse engineer each part thereof of Cleveland's to be able to apply for the design approval on the drawings, the material specs, everything listed there, in a big packet to send off to the FAA to be able to proceed with the testing to show that our product was equal to or better than that of the Cleveland. Okay, so at this point, we sent that packet off with all the drawings and all the part numbers and all the measurements, everything. And what we had to do was the next step was testing. After we got that approval on that packet we sent to the FAA, we had to test it. We had to test our product, Cleveland's product, to our product. Okay, and so we on the test bed that we had to was very, very extreme. We took a Cheyenne 4 at 10,330 pound landing weight, 90 knot landing speed, no flaps, no reverse thrust, and we had to decelerate at a rate of 10 feet per second squared. Okay, so as you can see, it created 1.7 million and some change foot-pounds of kinetic energy to stop that brake. So this was all on a machine. Okay, the 10 feet per second squared equates to that aircraft at that weight stopping in approximately 12 seconds and in 240 meters on average. So what we did was we did this. This is the machine we were testing it on. Okay, so in a little video. Watch your volume, everybody, because it's kind of shocking at first, but I don't know how loud your speakers are, but here we go. So what it's doing now is that it's doing the accelerating the 90 knot landing speed, no flaps, no reverse thrust, and it's programmed to decelerate at that 10 feet per second squared. So that was one stop. Okay, we had to do that to failure on Cleveland to get our baseline. Okay, and our baseline on that was 32 stops until Cleveland's part failed. Failure was separation of the friction part of the disc from the hat part of the disc. Okay, so again, these are both our linings and both Cleveland's linings and disc on ours. They failed at 32 stops. Okay, what we did was we stopped at 34. Okay, where ours was still together. We could have done maybe 35, but we could have failed on 35, but we stopped at 34 because we were equal to or better than that of Cleveland's. Okay, so at that point, we have our first article. Okay, we know it works on a machine just fine. Okay, but we had to take that and put our lining in our disc after we were equal to or better than that of Cleveland's, and in this case, it was better than. And we had to put it on a Cheyenne 4 and make sure that that aircraft could do just a regular, normal takeoff and landing 3 times during that flight test. Okay, so our brake disc actually fit the Cheyenne 4 that we used, disc and linings rather. On flight test 3, takeoffs and landings stopped. At that point, with the FAA on site, they issued us the PMA. Now, since I was a Cheyenne 4, that was the bigger 12-inch disc. Since we did not have the 8 and 10-inch disc on the PMA side, that since all of our data that we submitted for the drawing approvals was everything being made to the same, to the specific drawings and such, they grandfathered everything in below it, the 10 and the 8-inch disc. So we did not have to do a flight test on or a dyno test on every brake disc. We just did it on that Cheyenne 4. So we get that PMA and we start making parts. Now the PMA, it's very good to know what you're putting on your aircraft, obviously, and PMA parts are identified by the letters FAA PMA. Okay, so my brake disc have on the side of the flange, the friction flange of the disc, we have engraved FAA PMA. Okay, now the name or trademark of the symbol of the PMA holder, in my case, that is APS black steel. That is also engraved on the side of the flange. Part numbers, to keep everything simple, we just kept the same part numbers as Cleveland or as Rapco, but in the case of Cleveland, just put an APS in front of it. In the case of Rapco, you're going to drop the RA and put an APS there. Okay. Now, the serial number or lot number, what we do is we assign a lot number to go with each group of disc or linings that we manufacture. And that is in the case that we have to do some kind of recall or what have you, we can trace those discs all the way back to the forging company, to the foundry, if something were to arise. Okay, we've never had to do that, but in this case, we had to show how we can go and get the stuff back properly to the FAA in our design approval. The eligibility for the type certificated aircraft, that is for every aircraft out there. So when Piper, when Cessna, when Mooney comes out with a new model of aircraft, we won't have to do the flight test or the dyno test on that. But what we have to do is we have to apply showing that our part number, APS, blah, 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 is the same as Cleveland's part number, blah, blah, blah. So we just have to submit the paperwork to Chicago and wait for their blessing to get that added to our eligibility list. The manufacturing and the quality control of the brakes. Okay, this is the front of our building here in Granite City. Okay, we've been here. Our company has changed roles to where we're now strictly. We went from a parts distribution company to now strictly manufacturing. So now we have a couple of different companies within this one location. And here in Granite City, again, we're 10 minutes from downtown St. Louis. But onto our brake disc. All of our discs are machined from a one-piece steel forging. Now, what I mean by that is we were the first company from the 5-inch disc all the way up to the 12-inch disc to introduce a one-piece steel forging brake disc. Okay, this makes a stronger brake disc for you. Okay, 60%, as it says, 60% of the material of the forging is machined from that piece. Okay, that's what they start off looking like. Okay, so we get these forgings in from the foundry just like this, and from there we, as you can tell, we organize and lot and serialize each for the to be able to use and whenever we have an order pop up. Okay, so we've got two different warehouses. This is our front warehouse with it showing all of our machines. Okay, these machines are really big, really heavy, really expensive, but they are very, very hard to use. Okay, so we've got our skilled technicians that are trained to use these to machine the brake disc. Everything is done computerized. Okay, and right here, I don't know if that's working. Right there is the machine where we program into to set up the jaws and the cutting tools to make each particular part number brake disc. Okay, so the life of a brake disc, so we say we have we're making a 50 brake disc, 50 of this part number brake disc. Okay, so we pull whichever lot we use. Okay, and we get them ready for for the machining part. Now this is the inside of one of our lathes. Okay, we've got right here where the forging is mounted. Okay, and the cutting tool there, or that's a drilling tool and that's a cutting tool to be able to machine that material off of that. After we machine all that material off, we're ready to go to our first QC for this particular part number of brake disc. Okay, and I say first QC. If you notice, our brake disc are still silver. Okay, so these are freshly machined, and we go into our QMM. Okay, where this machine right here measures 76 different critical points on that brake disc to make sure that it falls within dimensions on the drawing. Okay, so at this point, from there we just we box them up after they all QC. Okay, we have to QC a certain percentage of the 50 brake discs that we were making. So in that case, it would be 5%. We QC a proper amount, and from there we send them off to be heat treated. Okay, that heat treatment is I believe that heat treatment, okay, is our key, our that's what makes our brake disc last longer and perform better than that of the OE and the other PMA. Okay, so we send these brake discs off to be heat treated, which we'll talk a little bit more about in the coming slides, and then we get them back. So we get them back, and when I said earlier we had to QC them the first time, we now have to QC it a second time, the same percentage of whatever lot we sent out, to show that we did not alter or change the design of that brake disc, since we put that added step of the heat treating process. Okay, so from there, we QC that same amount, that same 5 or 10% amount, depending on the lot size. And from there, we are able to, after they pass the QC, we QC that certain percentage. And we show that it's all good. We do have, we put 8130s with all of our parts. Okay. And in this case, after we start to box them, after we do that second QC, we are actually, we have this sticker on the outside of our boxes where it says, obviously, stop. Before installing, please remove the protective coating with MEK, alcohol, or acetone. I have gotten the call before, Ben, hey, I'm rubbing. I can't, I'm using MEK. I can't get that black color off of this disc. Okay. And, you'll be rubbing for quite some time, for that black color to come off of that brake disc. Okay. What that protective coating, what they're talking about is that there may be some leftover machining oil on those brake discs, as they're bagged up from the heat treating process. So from that, that's what we're saying to wipe off with the MEK. So, and this is just a picture of our back warehouse showing everything that we stock. The linings and the disc both. So, and we do cover everything from the small Diamond aircraft up through the King Air aircraft that have had the Cleveland conversion, as well as the bigger Air Tractor 802s. They've got the bigger forging on them as well. So that said, we have the full gamut of brake parts available. Picture of our shipping department, and all of that. But product improvements, as I said before, APS is always striving to make a better product. Okay, which firsthand is that the heat treating process we put our disc through. Okay, with that, that's the final step in the machining process, the manufacturing process, where we introduce nitrogen and sodium in liquid form at a very high temperature to the surface of that disc. What that does is, that black color, the black steel, is the byproduct of the heat treatment. Okay, so again, that black color is not going to come off. Now on the friction surface, may turn to more of a dull dark gray, but that heat treatment has penetrated through beyond wear dimension of that brake disc. So what that does for you, it's not going to rust, pit, or corrode on you, nor will it, it gives you longer life. We have proven when you use them together with our semi-metallic Kevlar base pads, as well as our copper flashed metallic pads, with the copper flash backing plate, you will get longer life on these compared to the Rapco equivalent and the Cleveland equivalent. So again, that heat treatment, it's similar to what Lycoming does to the front end of their crankshafts, but they use nitrogen and ammonia. We're using nitrogen and sodium. Okay, so this it's making that a stronger steel. Okay, and that's what gives our brake disc the black steel appearance. Another product improvement we've gone through is our blended radius on the drilled disc. Okay, so this would be like the Twin Commanders. This would be like the I believe the 802s have this, but and I say Twin Commanders because this is where we first found out about it. We were having problems. Well, we heard in the field before it got to a problem state that that it was cracking. Before we started doing this blended radius, we were just drilling it straight down where there would be a 90 degree edge right there on that drill. Okay, so that was a cause, that was a attraction for high stresses, right? From there to there, and there was problems with it cracking from the hole to the inside part of the disc. Okay, so that's when we went to the drawing board and with our engineers, and we did this, implemented this. We were the first to implement this blended radius, and we actually do it on both sides of the friction part of the disc, top and bottom, where the OE only does it on the bottom. Okay, so that again, that's just a improvement we're wanting to make, and we were the first to catch it, and because everybody was doing it, but we were the first to catch it and address the problem. Improvement, our semi-metallic pads, we put Kevlar in our pads, and Kevlar base material offers a better heat transfer and longer life on your linings. Same thing on the metallic side. If you notice the two different colors right there on the backing plate and between the backing plate and the friction part of the lining, we actually copper flash the steel backing plate that the friction material is adhered to on that backing plate. And what that does is it offers a better heat transfer. It's a corrosion inhibitor, and it gives you that longer life with the transfer material there. And finally, it's a better bonding agent for that friction material to stick to that backing plate. So these are going to be the linings for your heavier, faster landing aircraft. Okay, and again, what we did was for product improvement, Cleveland came out with a product information bulletin, or they came out with a new lining, the 66-15-300, which is for the Cessna 208. Okay, so all it is it's a lining that is 35% thicker to the original equipped lining for the Caravans. Okay, and what we did was, what Cleveland did is to get this and be able to use their linings on their brakes, you had to convert their brakes from a 30-182 to a 30-182A. All that conversion was a data tag. All that data tag was about $700 to be able to convert your brake disc. So what we did is, for the Caravan operators, we PMA'd our linings to the aircraft, not to the brake assembly. So if it had a 30-182, if it had a 30-182A, you could use our linings for that, which is the extended life lining. Okay. The break-in theory of the disc and the pads. And again, that's the most important thing you can do on a brake lining and disc change, is to break them in. And this is so you can get the longest life of your linings and your disc through your properly conditioned items. Okay. Whatever you want to call it, breaking in, bedding in, burnishing, it's the same principle, just do it. Okay. But, before we get on to the braking procedure, what do we ask our brakes to do aside from stop? We're converting that kinetic energy, the energy in motion, to the thermal energy by use of friction. Okay, so the kinetic energy is 1/2 times the mass times the velocity squared. In the case of a 172 coming in on final approach at 60 knots at 2,400 pounds, that could create 159,000 foot-pounds of kinetic energy to stop that aircraft. Now, that's not, in any case, that's not what the aircraft is going to do, because that we just have to prove that it can do that. Okay, because that's not factoring in the flaps, that's not factoring in the drag of the aircraft, that's not factoring in the friction of the tires on the pavement after the aircraft lands. But the worst case scenario on paper, it can take that much to stop that aircraft. But we have two different pads. So we've got the semi-metallic pads and the metallic pads. Okay, that semi-metallic pad is an abrasive type material. So that abrasive type braking system is going to wear the linings out, it's going to wear the disc out, and till they meet their minimums, you remove and replace them. Okay, on the metallic side, that's more of an adherent type braking system, where you want to adhere the brake lining material to the surface of the disc to allow the linings to wear, not the disc. Okay, but so we'll start with the abrasive. On the abrasive side, the semi-metallic linings, that operates at a lower heat range, 100 to 600 degrees Fahrenheit. Okay, with that, it's primarily a graphite material on the lining side, but it does have that Kevlar in it. Okay, so this is going to be for your lighter, slower landing aircraft. Okay, and you're generating that friction on the linings, between the linings and the disc, to be able to stop the aircraft. Okay, and then as it says, the semi-metallic brake linings are riveted onto the pressure and backing plates accordingly to be able to be installed on the aircraft. Okay, the semi-metallic, again, repetitive. They're abrasive. The braking procedure is used to cure the resins within that lining upon installation. Okay, you just don't want them to glaze over or get too hot on the first application of the brakes, because that could cause cracking or again glazing on the surface of the lining, prematurely wearing your linings. Okay, so the cracking would be out of the rivet holes up here. Okay, if they were to get too hot on that first application. But how do we break them in? Okay, so what we're going to do is to break these in. These would be the linings for like your 172. You're going to taxi the aircraft for 1,500 feet at 1,700 RPM, applying the brake pedal force as necessary to maintain that 5 to 10 mile an hour speed. So you're just doing a slow taxi, maintaining a 5 to 10 mile an hour speed, a brisk walk, and then gently tapping your brakes. And all you're doing is curing those resins within those linings. Okay, allow the brakes to cool 10 to 15 minutes. Come out, you're gonna do a static run up. After that static run up, or during that static run up rather, as you increase the power with the brake pedals pressed, if you don't creep forward, the linings and the disc are broken in. But if you creep forward, you're going to repeat that first step. These break in very easy. The key point on this break-in procedure is just don't get them too hot. Okay, because you don't want them to glaze over. But different type of braking system on the metallic linings. Okay, that's the adherent. So that's going to be operating at that higher heat range at 600 to 1,200 degree Fahrenheit, because the friction material on this is primarily iron in that on the surface of that pad. So it's going to be operating at that higher 600 to 1,200 degree Fahrenheit range. Okay, on the adherent system, you're going to want to obviously adhere a layer of lining material from the surface of the lining to the surface of the disc. What this is going to do is it's going to allow the smooth operation of your brake linings and brake disc to be able to wear the linings out and not the disc. Okay, and but you want that layer of lining material to be all surfaced all the way across that friction part of the disc. Okay, so that layer has to be thin. So how do we do this though? What we do is we're going to taxi that aircraft 30 to 35 knots. Okay, after you change the linings out, after you change the disc out, after you change the linings and the disc out, so any of the variations there, you need to break them in. So taxi the aircraft at a high rate of speed to 30 to 35 knots. You're going to apply the brakes slightly heavier than normal pressure, coming to a complete stop twice. Okay, so what you're going to be doing is you're going to be generating a lot of heat to transfer that layer of lining material from the lining to the surface of that disc. And again, you're going to do it a second time. Do not let the brakes cool between stop 1 and stop 2. Okay, but after you do stop 2, you're going to allow the brakes to cool 10 to 15 minutes. Don't set the parking brake. Okay, come back, and then you're gonna do a static run up. As you increase the throttle with the brakes compressed, if you don't creep forward, they're broken in. But if you creep forward, that means that you did not transfer a layer of lining material from the lining to the disc on part of that stop, and then you need to repeat that step again. Okay, so I've got some pictures of some linings and some disc. If you see in the lower right here, the shiny part, that's the part that did not transfer. So those are glazed over. Okay, so that looks good up there. So just a little bit there. And this is off of a 414, but a Cessna 414. And the mechanic called me up and was complaining that the aircraft had spongy brakes upon application. Okay, so this is just showing here the material of it being glazed over. Okay, here's another one. This is off of a King Air. Okay, so showing the material there. This was all due in part because of the glazing and then the heat, because once it glazes over, you're relying on the pedals of the aircraft to stop that aircraft, because when the lining is glazed over like it is right here, it's just spinning on that brake disc. Here's that 414, also the brake disc, what it looked like. So the darker part here, from the 6:30 position to about the 9 o'clock position, that dark spot, that it broke in there, and then the rest of the disc was not broken in properly. So that just tells me that he changed the brake disc out and did not do a braking procedure. And then this was from the first application of the brake disc, and it just got worse and worse and worse as time progressed. So from there, the symptoms of the poor break-in. Okay, you're going to have the poor stopping performance, failure to hold during the static run, during the static check, the static run up, the vibration or judder within the pedal. Okay, that's going to be from the glazed part rubbing up against the part of the brake disc that does not have the material transferred. On the semi-metallic side, you're going to have the cracks or the fissures in the brake pad material, which is all going to cause an accelerated wear of the linings and the disc. On the metallic side, you're going to that uneven layer of transfer, that material being transferred, is what is crucial. It's what needs to be done for your linings to last as long as they should. Okay, but this is all just talking about the variations of the thickness and what can cause the vibration and such. But here's a brake disc that is fairly broken in broken in pretty good. There's some spots at the 7 o'clock position and maybe the 4:30 position that they released the brakes and did not transfer the material properly, but that's a pretty good brake disc broken in. Okay, so for your brakes to operate as they should properly and to get the life that you should, the break-in is crucial. Okay. Now, the basic maintenance awareness for my brake linings and brake disc, since we are a direct replacement for that of the OEM, all of our measurements are going to be the same, linings and disc, as Cleveland's, because that black color, again, on the brake disc is not a coating. So that doesn't add thickness to the disc. It just helps penetrates, making that brake disc a stronger brake disc. Okay. All the minimum wear on the brake disc are the same as Cleveland. So you can use that little green book I'm sure everybody has in the bottom of their toolbox for reference. But all the measurements are going to be the same. Okay. On the semi-metallic side, don't, the big thing that all I can say is don't over tighten your rivets. I actually got off the phone with a guy day before yesterday, or no, I'm sorry, it would have been Friday, I guess, or Thursday rather. And he 802, air tractor 802, and he went down, the lining cracked in half because he put too much pressure on the rivet tool, compressing that rivet. So just be careful when you're tightening those rivets to not over tighten them. And then the minimum thickness for the linings are going to be the same as Cleveland's at the 10th of an inch. Okay. Just some basic what ifs, warp pressure plates that could cause the binding of the wheel and the tire rotation. But it is all just basic stuff that they put in here. But with the brake linings not being broken in properly, they are going to wear faster than if they are broken in. Okay, so that's what I just want there to be known, is that I want your linings and your disc to last as long as they can. No need in prematurely changing your linings on your disc. As far as the other PMAs that we have, we just received, I guess almost probably going on about a year. We got the kit for the PC12, the brake overhaul kit. So we're getting into the multi-disc brakes. We've got a couple more coming here in the near future if we can ever get our approval from Chicago. With this whole virus thing, it's put a damper on everything, just like it has with everybody else. But the PC12 with more to come. Okay, it's just showing everything in the kit. These are the multi-disc brakes that have to be overhauled by a repair station or a overhaul shop. We hold the approval for the Continental and Lycoming silicone valve cover gaskets, similar to what Superior and the old ECI, which I guess is now Continental, but I guess there's a couple other vendors out there, but we hold the approval and eligibility for everything on those, Continental and Lycoming. Okay, the Lycoming drain back lines, which get bent real easy and everything, but we hold that, which is to compete with the Lycoming and Superior equivalents to help lower the cost on everything. for like the Cirrus SR22, we do the Plenum and the cross flow induction for the 550N that is on the SR22s, which is really just us and Continental. So very big price difference, and it's all PMA'd. Okay. Everything can be found on our website, where to buy them, who to buy them from, the FAA paperwork, everything, the eligibility, apsbrakes.com. But that's really all I have for y'all, and I appreciate you sitting through this. If there's any questions, I guess now's the time.
We do not have any questions at this time.
Perfect. Okay. Well, I thank you, everybody, and looks like we're right on time, and hope you all have a good one, and let me know if you have any questions.